Hello guys, I welcome you all to my channel Engineers Academy. Do subscribe my channel if you haven't done it yet. Now we are going to solve this problem that says that the board is used to hold the end of a four-way lug wrench in the position shown when the man applies a force of 100 Newton. Determine the magnitude of the moment produced by this force about the x-axis. Force F lies in vertical plane. So the man applies this force F, which is lying in the vertical plane. So by the vertical plane, it means that the force is in the plane which is parallel to the YZ axis, and this force is making 60-degree with the horizontal, with the y-axis, right? So if we draw the free body diagram, so let's say this is our tire and the force F is acting somewhere here, and this is our positive y-axis, this is our positive z-axis, and the x-axis is out of the screen, and this force F is lying in the YZ vertical plane and it is making 60 degrees. So we can resolve this force F into its components. We will have two components. This one is the cos component, this one is the sine component. So in the first problem, we are required to determine the magnitude of the moment produced about the z-axis. So let's say that the center of the tire is, let's say, represented by O. So if we find the moment about point O in this free body diagram, that will be equal to the moment about x-axis. So let me write that the moment about x-axis will be equal to the moment about point O. So, and let's say that we want to find the moment by using both the methods, that is the scalar approach and the vector approach. So first of all, I'm going to find the moment about the x-axis by using this scalar method or the scalar approach. So as we can see that by using the scalar method, we can always use this formula, m is equal to f times d. D is the moment arm. So by using the Varignon's theorem, as we can see that this cos component, this is passing through that point O or the x-axis. So this component is not going to produce the moment about the x-axis. Or in other words, we can say that the perpendicular distance of this cos component from the point O or the x-axis is 0. If we draw that cos component here, so its perpendicular distance from the x-axis is 0. So it's not going to produce the moment about the x-axis. So the only sine component is producing the moment about the x-axis, since it is at a distance of 250 mm. Here we are given that this force is acting at a distance of 250 mm. So the perpendicular distance of the sine component from point O or from the x-axis is 250 mm, or in other words, it is 0.25 meters. So we can write that the magnitude of the moment about point X, about the x-axis, is this will be equal to f cos of 60 into 0 plus f sine of 60 into the perpendicular distance, which is 250 mm. This is 250 mm, right? This distance is 250. So 250 divided by 1000 will give us 0.25. So this is 0, this will become 0, 0 plus that. So that is 0.25 f sine of 60. So this is the magnitude of the moment about the x-axis. So now if I put F equals to 100, since in the problem statement it is given that the man applies 100 Newton force, so then we can find the magnitude of the moment about the x-axis. This is 0.25 into 100 into sine of 60. So 0.25 multiplied by 100 multiplied by sine of 60, this gives us 21.65. So 21.65, and the units will be Newton meter. So this is the solution of the 458 problem by using the scalar method. Now we will use the vector method as well. So vector method. So now by using the vector method, we can say that the moment about the x-axis is, or we can say that the moment produced by the force F, that will be equal to the moment arm cross the moment arm vector cross product with the force vector. So now first of all we have to define our moment arm vector. So our moment arm vector can be a position vector from from here to here, let's say, right? And our moment arm is parallel to the y-axis, or we can define our moment arm from the origin, since as we can see that this force F is acting at a distance of 250 mm from the y-axis, right? So the origin is 250 mm away from this point of application of this force F. So if we define our moment arm, let's say that the point of application of this force F is, let's say, point A, and let's say that the origin is at point O. Let me draw this at the 3D diagram. Let's say this is my positive Z, this is my positive Y, this is my positive X, and that force F is acting somewhere here. This is the application of that force F. That force F is acting somewhere here. This is that point O, and this is the application of that force F. Let's say that this is point A. So we can define our moment arm is a position vector from O to A. So we can say that this is the position vector from O to A, and this is the force F as a Cartesian vector. So first of all we have to write this force F as a Cartesian vector. So as we know that this force F is acting in the vertical plane, so it has two components. So we can represent this force F as a Cartesian vector. So this force F, this is equal to, this cos component is acting along the y-axis. So since force F is in the vertical plane, so its x component is 0. So we will write that this is 0 I plus F cos of 60j, since the cos component is acting in the positive j, and the z component, this is the z component which is parallel to the z axis, is acting in the negative z. So this is minus F sine of 60 in the negative k. And the position vector from O to A, we can find the position vector from O to A. So the position vector from O to A is, so we need to move from O to reach that point A. So first of all we need to travel 250 mm in the positive x, or 0.25 meters in the positive x. So 0.25 meters in the positive x, so that is in the positive I. And then from here we need to travel 0.25 meters in the positive j. So plus 0.25 in the positive j, and there is no need to travel in the positive k since we have reached point A, and there is no need to travel in the z direction. So this is 0k. So now we can find the moment. This will give us moment vector, remember. This will not give us magnitude. In the problem statement we are required to find the moment magnitude. So once we find the moment vector, we will be able to find its magnitude. So the components of the moment arm, that is 0.25 along the j and 0 along the k, and the force component is 0, and then F cos of 60 and minus F sine of 60. Now let's find this determinant. So for I we have to hide this and this minus this, right? So 0.25 into minus F sine of 60 into I, and then for j we have to hide this and this and this and this, so this is 0. So 0j, right? So 0j. And now for k we have to hide this and this, so this minus 0, right? So 0.25 F cos of 60 k. So this is the general moment vector for any F. For any given magnitude of F, this will give us the moment of that given force about point O, right? Since we have defined that this is the position vector from O to A. So in other words, this is the moment about point O. Remember, this is the moment about point O. Now we can write that this, let me simplify this. So this will be minus 0.25 f sine of 60I plus 0j plus 0.25 cos of 60k. Now if you want to find the moment along the x-axis, since we are required to find the moment about the x-axis, so we need to write that the moment about the x-axis, this will be equal to the moment about O, and we will take the dot product with the unit vector along the x-axis. So the unit vector along the x-axis is I k, right? The I is the unit vector along the x-axis. So this means that we need to take the dot product of this vector with I, with the unit vector I. So this is minus 0.25 f sine of 60 I plus 0j plus 0.2 f cos of 60k, and dot product with the unit vector I. So now as we know that while taking the dot product, I dot I is always equal to 1 and I dot j and k dot I is 0, right? So this means that we can only multiply this and this, right? So this will give us minus 0.25 f sine of 60, and I dot I will be equal to 1. Similarly, 0j into I will become 0, and similarly this 0.25 f cos of 60 and k dot I will become 0 as well. So the moment about the x-axis is, and remember that this dot product will never give us vector, right? So there is no need to write the vector symbol. This will give us the magnitude. So this is the moment about the x magnitude, right? So this is minus 0.25 f sine of 60. Now the minus sign tells us that the moment produced is the clockwise moment, right? And as we can see that if we look into this sign component, so it is producing the moment about the x-axis in this direction, that is in the clockwise direction, like this. And if we curl our right hand fingers in this direction, so our thumb will point out in the negative x. So this means that this moment which is 21.65 Newton meter, this is the clockwise moment. So let me write that this is clockwise moment. So similarly here we get that same 0.25 f sine of 60 using the vector approach, and here we get the negative sign. So the negative sign tells us that this is the clockwise moment. Now if we want to find that magnitude, we need to put f equals to 100, and that will give us that same value, that is 21.65 Newton meter. So this is using both the approaches. Now it's up to you. In the problem statement it is not said that using the particular method, right? So you people can find the magnitude by using the scalar method or the vector method. Now in the next problem, that is 459, it is said that again the same problem, the board is used to hold the end of 4-way lug wrench in position. If a torque of 30 Newton meter about the x-axis is required to tighten the nut, determine the required magnitude of the force that 9 foot must apply on the end of the wrench in order to turn it. Force F lies in the vertical plane. Now in this problem, the magnitude of the moment about the x-axis is given. If a torque of 30 Newton meter about the x-axis, so mx is given, mx magnitude is given. So this is problem 459 solution. So in this problem, mx magnitude is given, which is 30 Newton. So now we can put that mx magnitude in this equation, which is the general equation for any given force F. So we can write that this is 0.25 F sine of 60 equals to 30. So from this we can say that F is 30 divided by 0.25 sine of 60. So this is 30 divided by 0.25 sine of 60. This gives us 138.56. 138.56 Newton meter. So if 30 Newton meter torque is, this is 30 Newton meter. If 30 Newton meter torque is required to tighten the nut about the x-axis is, so the main must apply 138.56 Newton meter. And in the first problem, it is we can see that if the force magnitude is 100 Newton, the moment about the x-axis is 21.65, which is less than this 30 Newton meter torque. So for 30 Newton meter torque, the force must be greater than 100 Newton, and which is greater than 100 Newton. So this is the solution of this particular problem. I hope this will help you in your learning. Do subscribe Engineers Academy for the solution of such more problems from Hibbeler Statics.